Okay, so I decided to make this first slide again as a result of the conversations I've had in this talk so far when 2DX was actually compared to an iPod. Not so much to make a shameless kind of bid or a sales pitch for Apple products, which I think are very cool, but more to just kind of segue into a description of Apple's central philosophy, which has absolutely nothing to do with electron microscopy or image processing, but I think it's important to just kind of go into that for a minute. So the first couple of minutes of my talk will probably sound a bit like a sales pitch, but I think the philosophy and dogma are really important things to keep focused on in developing software or algorithms or science in general. So this up here is an iPod. It plays music, it plays video. Basically, the minimal amount of user interaction you need to go through your music library is to be able to go forward, back, play, pause, stop, and adjust the volume. That's the minimum amount that you'd ever want to do with your music library. So Apple decided that's all the user should see right out of the gate. You should really just see the minimum amount that you need to actually get things done. Now, is that all an iPod can do? Not at all. There are people that have actually loaded Linux onto these things. I think you can get keyboard attachments. You can make this a PDA if you want. I mean, it's essentially a tiny computer. So the idea that Apple has got is trying to make kind of successive layers of abstraction, starting at the top very generally, so a user can take it out of the box, push a button, and have it work. But also kind of going into deeper layers where you can finally just get down to the hardware, hopefully very easily, but always seeing exactly what you need or want to do with your software or your algorithm or your scientific method. And so hopefully that little brief introduction will become a bit clearer in the next few slides, because it's really what we've been trying to do when developing 2DX. So a little bit of the philosophy and dogma of where we've been going by way of lessons from image processing, from discussions I've had with you over the last week, and also just what we've been developing for the last few months, what I've been hearing in emails and so on. I think consistently, with a few exceptions, I think automation is probably the biggest thing I hear from labs. A lot of people do want to do manual determination of a lot of the variables, and I think that absolutely must be there for whatever software you're doing for image processing. But also, a script that runs for a week or 24 hours certainly shouldn't be introducing questions to the user that aren't relevant. I mean, you shouldn't be interrupted every 15 minutes to click a next button, for instance, when you're processing. It will take forever. You should be able to automate to the point that you want to automate, to the point that automation makes sense. Another one that I hear a lot of is consistent application of methods. Being able to do exactly the same conditions to every image you process using some sort of algorithm that you've come up with in your lab, using parameters that are always the same or at least adjustable and then consistently applied throughout. And this will result in less time tuning and retuning things. From what I understand, many of you are using shell scripts that are calling MRC programs, and in a lot of these cases, there are statically defined variables in those scripts that make sense for the particular image you're making or processing, but which from time to time, every few months, you might want to change, but generally just kind of get in the way. So more throughput. Another one, easier. I'll be talking about that and the questionable trade-off between ease and flexibility in the next few slides. And that kind of just goes directly into more or less flexibility. In general, more comes up a lot. We really like this image processing package, except it doesn't do the following, or great, this is good, but only for single particles, etc. Also, less flexibility frequently comes up. This is an incredible software package, but we don't know how to use it. There are too many parameters. I can't just process an image for screening purposes. So yeah, we find that our method, or that the following method doesn't work. We've used some other method, and we'd like to be able to use that. We'd like everything else that the package does, just not this bit. And then a really common one, does it run on my home-built Gen 2 system running on DEX Alpha or DEC Alpha? And so platform independence, another big one. So we kind of organized all of these when developing 2DX. And so the first principle I put up somewhat facetiously here, but I think it is kind of important to keep in mind as you're processing images that you should be able to process images. Your software should actually be scientifically valid and useful, and not simply used for visualization or kind of simplification steps, but actually be a viable process. Ideally, 2DX should be exactly what you have in your lab, plus a little bit more based on what you configure. And that leads right into maintaining rigor. I'm a firm believer in mathematical rigor, in scientific rigor, and maintaining that has been my first priority in 2DX. And I think that next one, ease of use, is frequently seen as kind of the other side of the counterbalance. Everybody always wants to say that ease of use and rigor are kind of on either side of a teeter-totter. You can have more or of one or the other, but you're not going to get both. And I disagree. I think you can have both, and I think that discussion of Apple products in the beginning shows that very thing. We can make successive layers of abstraction where we introduce users and processors to variables of import at their discretion and at their leisure. And once you get it set up, either via default or your own sort of setup, ideally it should be as easy to use as you want it to be, but it should still be fully customizable. So I think that these aren't so much at odds as they are the same principle. Again, I said this last slide, interface should demand no more attention than is required, and optional parameters should remain optional. The script shouldn't be calling them up saying, should I continue, when that's really the only question. The other one that's been really important to me is trying to address issues that are important to the community. I've gotten a lot of great ideas from talking to you guys during lunch and dinner over the last week here, and I'll definitely be implementing those as we go along. But as a programmer, frequently it's easy to just start going off on some tangent that seems important to you, but isn't actually useful to the community at large. So I kind of wanted to avoid that by listening to emails and responses and so on. And we've kept this very open and community-oriented, I hope, in development and continual refinement. And yeah, 2DX should run on every platform available. And at the moment, it does compile on just about everything. We've been trying to produce custom builds for individual platforms, and that's been interesting. We'll be talking about that a bit more later today. There's this American phrase, I don't know if you know it in Europe, 2DX is as 2DX does. They don't say 2DX, of course. That's never really made sense to me, but I decided to put it here because it kind of made sense in this context. It's kind of what I was saying before. This should be an interface. It should do exactly what it needs to do and no more. MRC, Spider, Eman, there are plenty of image processing packages out there that do what they do phenomenally well, and we don't need to be reinventing parts of the wheel or axles or anything like that already exist. We really just need to organize it and present parameters and allow users to interact with it in a useful way. Yeah.
So there's a lot of effort trying to integrate different programs with each other. Are you part of that?
Yeah.
Stalks and all these sort of things?
Yeah, absolutely.
Yeah.
Yeah. Smart.
We are not.
Okay. Sorry, did I answer your question?
Not yet.
Granted?
It's an option. I have not had the time to do that.
Well, I can possibly answer that question a bit further and why I said yes immediately by showing what we've been developing with. Qt from Trolltech is a development API that they've invented. It's downright mathematical in its implementation. It's one of the most beautiful APIs I've ever encountered. It's kind of a meta API that allows you to do windowing, of course, to do graphics on any platform you could possibly imagine, as well as a number of other things. Just about any data structure you could possibly want is available, from queues and stats and so on. String manipulation, you can use network stuff. I mean, it's got everything. And it's completely platform independent. And when I say platform independent, I mean these run on cell phones and iPods out there. So in principle, the basic software should be compilable on just about any platform available, which is why I'm hesitating to say yes. Do we have anything right now is a separate question. But of course, it's all open source, so you're free to play as you like. As I said, it's platform independent, and it's open source, so 2DX is also, and that's been important from the beginning. We want this to be kind of a community-based project. Just a quick little discussion of Qt. The most famous, or at least possibly well-known, example of Qt-based software is the desktop KDE, which is written entirely in it. And as a result, every KDE program specifically written for it is also in Qt. So it's very fast, very well maintained, very well documented, and so on. So just getting to the hierarchy, 2DX itself is an entire image processing platform, which encompasses a number of overall options. We've got a manager, which is kind of an organizational tool, which basically creates a structure, a folder hierarchy that allows you to put your images according to tilt series and other parameters. We've got a merger that allows you to do 2D and 3D reconstruction. We've got a little log browser to describe what's going on at every step of the way. And centrally, what I'll be talking about in this talk, we've got 2DX image, which allows you to do 2D reconstruction without merging at the moment on a specific image that can then be used in the later merging process. Now, the overall 2DX package is independent of implementation, but we've given a kind of default image processing workflow and package that's based entirely on MRC, with a slightly modified MRC core. And when I say modified, I mean a lot of what we've done is sort of syntactic upgrades, and I use upgrades hesitantly. I just mean that we've massaged bits of MRC to work with G4Fan, which is a bit specific and pedantic in its implementation. So very simple things along the lines of changing parameter declarations in Fortran to use parentheses, whereas before it wasn't, or removing an encode statement or something like that. But by and large, the original MRC package is completely intact and is available as a distribution. It's kind of a merge of a 6-month-ago version of Image 2000 and some additional scripts and binaries that we've written in-house, including an X display, the automated scripts that Henning has been writing, lattice determination, as he just spoke about, tilt geometry, image masking, some things relating to image masking and unbending, and error field refinement. From the programming end, as I said, we've changed quite a bit to try and make the compilation more amenable to the G4Tran, and that's included making a generic makefile, a configuration script, kind of just like any Linux package out there, uses G4Tran, GCC 4.1, and we've swapped out the native FFT libraries for,
So when MLC is operating their software, will they do it in G4Tran as well? Or when they have an operate, you have to change everything to run it into you?
So, may I answer this?
yeah, please.
We downloaded the Image 2000 package half a year ago, and then I spoke with Richard Henderson and discussed all this with him, and he agreed with us distributing his modified code. So he said that's fine for him, but we should have a disclaimer saying that if you want the reads and the most latest bug fixes in the original MRC software, then you need to contact him. And on the same time, he took the Image 2000 distribution off the server. So from now on, if somebody wants to have the MRC software, you can't download it anymore. So we can't, except if you ask him directly. And so I guess every 1 or 2 years we will have to ask him for the recent upgrade, and then he has to give us his latest software version or not. So what we have at the moment is 6 months old. The bug fixes or new software that they introduce are not directly accessible for us anymore. So,
But is the Image 2000 not really developed?
I think Jude Smith, or Jude Shaw is her name now, is working on that, especially on X and this. And Richard Henderson himself, that I don't know how much energy or time they put into that. So.
Yeah, as we'll see in a minute, it doesn't much matter in terms of the distribution. You'll be able to input your own programs anyway. So if you get a version of Image 2000 later on working that you want to incorporate, it's very easy to just go ahead and throw it into this. So this is the hierarchy that's been proposed. Our manager makes a series of folders named generally by protein description, which is usually a 3 or 4 character specification, and that's organized into tilt-based folders. So in this case, it would be a protein of 0 tilt, 30 degrees, and so on, and they're incremented by 5-degree tilts. Just as organization, you just round the nearest. Inside each of these, you've got protein directories that 2DX image will then individually process on. And the schema here is, as again, the 3 to 4 character protein specification. a 2-character tilt, and then an 8-digit unique ID. And 2DX will then process on that visually. At the end, it'll take the config data from all of the series that you're working to do either a 2D reconstruction or generally a 3D reconstruction based on defaults and parameters that you've refined in each of these folders. I'll show you that now. This is the overall workflow, and this is kind of a meta algorithm, and it looks very simple because it is. When we started this process, we really thought about what we should do in terms of getting our software to process images. And we could have invented a new scripting language or used XML, or, I mean, a number of options were available to us, and those are all very good ideas. But taking a quick poll of everybody, as far as we were able to tell, most people use C# or Bash scripts to run MRC or other programs in their labs. And so the idea here was to try and just, out of the box, make this as easy to use with the current software that you have running in your lab immediately. And so when I say template, I really just mean a C# or Bash shell style script with a little bit of trimming at the top to allow it to interact with the 2DX front end. Now, it doesn't actually need that trimming, so in principle, you can take every script that you're running at the moment, drop it into one of our standard template or specific template directories, which I'll get to the distinction in a moment, and 2DX will automatically populate the image processing steps here on the left based on what it finds in those template directories. It won't name them according to any sort of special naming scheme. It'll just be script 1, 2, 3, 4, because there's nothing in there to sort of interact with the GUI, but it will actually process images according to the way that your script runs. So, yeah, again, these are some examples of some of the scripts we're using. As you can see, it's all just standard C shell. I don't know if that's readable at all. It's not really meant to be. Some more things in the next one will be. You can see that there are set commands, echo commands. There's a few interesting things that I'll be getting to in the next slide that are 2DX specific, but in general, it's exactly what you would think it would be. The differences occur here at the top in the header and then later on in the usage. So optionally, you can, again, every parameter, procedure, what have you that you see here is completely optional to you, and you can upgrade it based on your desire and make it flexible as you like. The first one is the title. This is kind of the unique identifier that we use within the context of 2DX to describe it in the image processing phase. A sort order, which allows the script to show up in an order that you tell it, so it's not alphabetical or anything like that. That's important because we do sequential execution in one of the folders as an option. You can put in individual variables, variables that are specific to this script but you don't want to have updated in the original sort of core database, which I'll get to in a bit. And then a section that controls the display, the parameters that are actually shown in the GUI that are taken from unique identifiers that are found in our parameter database. And so our entire UI, at least in terms of the parameters, the scripts, the output, and so on, is dynamically generated based on what you put in here. As soon as you're done with the local variables, there's just a short section here where we use a number of set commands followed by the end variables command here, or end bars, that 2DX uses to populate values with values from the database that the user has put in graphically or in the GUI, and then it can parse that, put them in, and then create a sort of proper C# script in the local directory. And so that's exactly what it does. It takes the template, it parses it, it merges them together in a common proc directory in your local image area, and at this point, these are sort of proper C# scripts. If you look at the output here, this is the result of one of those templates being processed. I think one of the ones I just showed. It's in every way a proper C# script with static variables being input based on 2DX's database. And this is executed sequentially, so there you have it. It's important to mention that these are proper scripts, and as a result, you can just quit 2DX if you want and just go into the local directory and start processing based on what you've got from there. And I find that quite useful for debugging. You can also just change the local scripts any way you like if you want to do some quick modifications, because the next time you run it, it'll reparse and write over them anyway. So this is the layout. again, the iPod iTunes connection should now be pretty clear. That's intentional. It's mainly just trying to make it user-friendly, straightforward, but again, as you just saw in the last slide, maintaining that rigor. What we've got up here on the upper left is a series of standard image processing routines. These are sorts of things that can be executed sequentially, and what you see up here is our in-house image processing routine that, algorithmically speaking, was presented in Hang's talk and Anshi's. Yeah?
How difficult would it be now to introduce an on-band-free circle?
Not at all. You would just put an on-band-free script and drop it into
and then true, that's server-side.
That's what they're saying.
That's what you mean.
Yeah, actually, N-Ven 2, I think, has a maximum of 5 or 6 cycles that can go through. But exactly, I mean, that's the sort of thing that you could create a script of, drop in the default directory, and it would just show up right there and could be executed as part of the selection. The ones below are specific scripts that are of import to image processing, but aren't particularly useful to be executed automatically. And so, for instance, we've got, this is an old image, but we've got a refine unbend parameters where it sort of does a brute force search of parameter space to try and optimize some quality values and IQ spots and so on, which we'll get to later. There's this central area which contains all of the relevant parameters. You keep a parameter database that I'll describe, I think, in the next slide, that organizes all of this data in a human-readable format. As you can see, not every one of these things is a text field. Some of them are drop-down menus. Some of them have these little walks. There's these sections. And there are other types, push buttons, and so on. And in each of these, the user can interact with them, change them by a drop-down or whatnot. And when you execute, all of the values found therein are going to be populated in the resulting script. So you can play or run your scripts up here via the 2 controls, and the output starts going immediately. Something I didn't talk about that was optional in your script output are progress updates. You can, via the standard out, send 2DX messages about where you are in your script. This is completely user-defined. We don't do any kind of automatic checking of just how long it takes to execute something. But you could, for instance, set the progress to 50% when you were halfway through the time it took to execute your script, not just halfway through the sequence. And also, we intercept the standard out and put it out to both a log file browser here, which is just sort of an active thing and is browsable in the same way that our full-fledged log browser is. But you can double-click the top bar here and view all of the log files that have been generated for the whole processing step, and in particular, this particular script. So it's got 3 verbosity modes, which you can control in the output by prepending a colon or 2 colons or nothing to determine just how much you want to display. In this case, we've got a moderate level of verbosity being shown, and more information is being shown than usual. You can also go to low verbosity, which shows very little, and you can get the full MRC output if you go to the highest. After a script has finished execution, again, by your command, you can output results and image files to a global results file, or excuse me, to a script results file. So in this case, this script is called 2dx_fftrans, and in the local directory, you can output a 2dx_fftrans.results file and set variables that are in this database and report to 2dx images that are of interest to the user. The user can then click on those images and get a small preview down here in the bottom left, or if you click the I button, you can get a header view similar to what Anshi showed yesterday. And then down here in the bottom right, these are the figures of merit that Henning was just showing. We've got an empirically determined quality value that we use, the formula for which is in the JSP article that should be in your binders. If you want, you can ask Henning further about that. But it just sort of empirically gives you a number which generally describes just how good your data set is and how good all of your unbending parameters are. We use this to try and tune these parameters via some of these specific scripts as we go along, also that you can tune them and see how far you've gone. The IQ values for the two unbending steps that we use are shown here, just sequentially, IQ 1, 2, 3, out to 9. And this is indicating just how many spots were found for each IQ. So this was a particularly good image, and it found 61, or most of the spots, as IQ 1, and very few for the rest of them. And again, same for IQ 2. Down here, obscured by the little thing in the bottom right, are some defocus and lattice parameters, as Henry just described. So the parameter database, we debated about this at the beginning. Should we use XML, HTML, something else? And I think we decided on going for something in between a shell script and kind of just our own little markup language. Well, I didn't even want to call it a language or a scripting environment. It's really just a series of flags that you can set for each variable. And the structure is as follows. You've got a section break up here at the top, and that controls what you were seeing back here in this page, these blue lines that organize the parameters based on what class they are and so on. And then you've got the variables themselves. The only thing you need to put into our database to define a variable is this last command, set unique identifier equal to what have you. If it doesn't have a label, it just won't show up as anything in 2DX. But again, all of this above is optional. But specifically, if you want it to be a bit more fleshed out, you can add a label, and that will show you the UID, the thing that you use to identify each one here on the left. There's a legend, an example, and a help, which all show up as a context-sensitive right-click on any of the parameters. The help allows you to link via a browser that you can define in a config file to online help if you like, and we've got that working for most of our, I think all of our parameters at this point. It connects to our 2DX documentation. There's a type that controls whether it's a text box, a drop-down menu, push button, anything. There's this concerns thing, which is sort of deprecated now, that allows you to determine what script the variable should show up on in if it's not explicitly defined. And then, of course, the set value, which just sets the default value for this particular variable. And you can just continue this and add them as you like.
And locked means?
Oh, and locked is, yeah, can you see here? Okay, good. The reciprocal lattice is the sort of thing that takes stages to manually refine, and you usually put a lot of work into it. And when you run through this sequence of scripts, it's going to automatically try and determine a lattice for you. And if it's allowed to do so, it will just overwrite what you've done and go on its way. The locks allow you to just lock down each individual parameter that you want, and it's untouchable then by either user control or by the scripts unless you unlock it. And you can see up here on the right, the lattice is in red, whereas the tilt axis and the others aren't, because these were successfully updated down here, whereas the lattice wasn't able to be. As you can see, they differ.
So then if you want to actually update it, you can unlock and then sort of push update and switch it again.
Exactly. Yeah, I think that's the parameter database. To keep away from legacy issues, and this is kind of a technical point that's not terribly important in execution, we made it so that there is a local config that's in the install directory. This can be changed at any time, but of course, the install directory is going to have a config, and then the local directories also have a config based on the parameters that you've saved. If you change this, in principle, you could have desyncing legacy issues, and they could go out of date very quickly. So what we end up doing actually is we create our database based on this information. We then merge the data that's found in here to correspond to values in here back into this, and then we save it back out. So you never really have to worry about what version you're using. If you change the database, it's fine to just go ahead and go back in and look at old images, and all the values that were in there before will be updated correctly, appropriately, and then saved out as you went. So, the procedural hierarchy, I think I've gone over a few times here so far, but I'll go over just once more. You can, via extended selection, select as many of these as you want. And when I say extended selection, I mean you can select 2, 3, and 5. You can select all of them, one of them, however you like. You can double click the top and select them all, and then click execute, and it'll start updating the progress bar at the top and outputting the log file information at the bottom. And when it gets to the end of a script, it'll output all the data to the images, the results, the status, and of course the parameters themselves. These images are then available for viewing by the user in preview mode, or in our more fully fledged graphical navigator, which allows you to do quite a bit. And I think I'll just go ahead and show you that right now with the program executing. So this is an actual example of 2DX. Some of you have seen this in the installation labs we've had, but you will definitely see it again today at 1:45 when we go through the general image processing. So you were immediately presented with a choose a folder or image directory that's based on the hierarchy I showed earlier. And it goes through, reads the local config file, and populates the data here based on what it finds therein. And all of this is available. The context-sensitive help that I was mentioning via a right click allows you to see the name of the variable, a little bit of help about it, and then if you click this, you can go to the internet help if you want. If it doesn't have one, that just won't show up. But the navigator is accessible via clicking one of these image files, which is shown over here in the image directory or in the image results pane. As you can see here, we've got a number of header information that's available for you, shows you the map mode and that sort of thing. But you can also click this little eye, and you've got the preview there, and it'll generate a preview automatically for you. And you can smart through it. We can also show PostScript files, which will be displayed based on your PostScript viewer that is in a config file. I'll just go ahead and show you the navigator. So if we double click on this, this will show us the power spectrum. If that's a bit dark, we can change the contrast on that. For image processing. Does that feel better? And then we've got almost everything that XMDisc can do available to us. Lattice refinement, CTF fitting, spot selection, and so on. And so I'll just show you that by the display window up here. For instance, the lattice, which I fit before, sadly, is available to the user via this L key. We've got a spot list, which doesn't show up because, there's a spot list which you can dynamically choose, and then there's a CTF range that you can plot, mainly the zeros here. And I'll just go through each of these actually really quickly. First, I'd like to show you the lattice information, and what I'm going to do beforehand is actually destroy the lattice that I've got in there just to show you what it will look like just out of the gate. And so this lattice is directly the one used to plot the lattice. As you can see now, it's completely incorrect. So for manual refinement, it's very similar to XMDisc. You can go back into this image, select individual spots, either in this view or by a control click, which gives you a zoom view. You can select per pixel. This is scalable as you like, so you can get in as deep as you want. These pixels are not square now, but zoom this way. On Macs, you can also zoom the whole image in and out. We've been having some issues stabilizing that with Linux, but anyway, there's that. So this is how you would refine a lattice manually in 2DX. You'd select your spot, usually very accurately by a right click and clicking directly on the spot. It would then propose a Miller index based on the current lattice that you have in the database, which is going to be wrong in this case. And so I'll go ahead and just say that this spot is 10, based on the canonical labeling that Henning just mentioned. We'll add that point. At the top, you see a candidate lattice based on the values that you've already got in the queue here. Of course, there's only 1 point, so there isn't a lattice to be discussed. And so we'll go ahead and add a second point. I'm going to use this one, although I'm sure it's the other one that's the correct one. Find that as 0, 1. And as you can see now, there's a rough cut candidate lattice that we can click accept. And if we go back here, we can view that candidate lattice right there. Now, if we want to continue to upgrade and add points and refine the lattice further, we can do so as we wish by clicking extra points. Now that we have a candidate lattice, it's going to do its very best to fit a Miller index to the closest available lattice point. And so in this case, it's populated this with Miller index -30. If that's incorrect, feel free to change it. But generally, by this point, they're always going to be correct. So you can just add a point and move on. As as you can see, it changed the lattice just a little bit, and you can see that in real time, that it just makes a micro adjustment to it. You can see what adjustment each point gives you as you go along. And of course, you can spend as much time with this as you like. That was an interesting point to add because it wasn't orthogonal, but the higher frequency you add, the better. And as you can see, the lattice is becoming increasingly well resolved to the point that I think this one looks pretty good. There's also a second lattice that you can display if you happen to have a bilayer with two crystal layers. This one won't show up at the moment because it's 0, 0, 0, but you can show a second one as well. Spot selection. So when you're generating a reference for unbending, you want to select spots as best as you're able. XMDisp allows you to do this very well. We wanted to make it pretty flexible also for spot selection, and so you can either show the lattice or not. Either way, you're picking spots on the lattice one way or the other, and you can just click them on and off as you like. Now, even though you're not seeing the lattice, it is still being picked according to the specification that's there. You can at any time go up to the navigator, down to your spot selection, and reload your peak list if you've made mistakes. Or you can also optionally go into spot selection and save it, or clear it as you like. And this allows manual. Of course, if you want to do it in the way that XMDisp allows it, you can show it by edit. Never mind, XMDisp does not allow this. And
doesn't have it.
So there we are. You can select spots via this way then, the way 2DX allows it. That process. The last point I'd like to bring up here before I close is the CTF correction. Now we use CTF find and to automatically determine ours, and that usually does a very good job. But in the cases where it doesn't, or in the cases where you want to manually refine it, you have a linear combination of x and y here in the form of defocus, which is their sum, and the astigmatism, which is their difference, and the angle. And so just to show you here, you can just go ahead and manually tune this as you like to either increase or decrease the parameters based on the database and change the astigmatism. And it's important to note that these aren't just idealized ellipses in terms of these zero crossings. Occasionally you can have severely astigmatic images that actually show zero crossings that are more hyperbolic than they are elliptical. And I am informed that this is actually possible in images and does appear from time to time. So you can do that as well. For this image, let's go ahead and go back. In the case where you do have a bit of astigmatism, you can also change the angle here manually as you like. Again, CTF Find does a phenomenal job though, and we use that for most of it. Again, all of these parameters can be automatically processed in the context of 2DX also to varying degrees of success. Yes?
So you can actually, on normal images, normal picture patterns, correct for the astigmatism and the angle of the astigmatism based on CTF Find the output you get. Can you also write out the images? Because the sprayer line, for example, can calculate for correct astigmatism. It doesn't write out images. It just keeps them as a content or something. So can you write out images as well?
Not yet, but that sounds like a great idea.
That would be great because
What kind of images? Exactly this one is not on screen.
yeah, no. I mean, like for example, single pass images. If you want to calculate single pass images, and you know the angle of astigmatism, and you won't actually correct that in CTF. There's no program which actually can do that, and at the same time writes out the images so that you can use them in a different program. Right now.
So you can write a script that corrects the CTF and writes that out. It's independent of the data.
I was wondering if your program doesn't by any chance.
If you apply TT mask to Fourier transformation of an image, then that writes out this transfer function corrected image into the file. The SNMRC program, you can just use that.
We're always very open to suggestions, though, in terms of this interface. We've got some rather cool ideas from various people about what they'd like. In particular, polygonal masking sounds like a great idea that I want to implement immediately. And also active windowing and Fourier transforms of particular sections of real space images should be in the next release. I'll just go ahead and finish there by thanking my entire lab, but in particular, Ning Stolberg and Shengyang Tseng, who's here somewhere, who did our algorithm, and thank you all for giving me ideas and giving us this forum to talk about. Thank you.
Two questions.
Sure.
One very specific. So when you do the embedding the digital images, you do the autocorrelation, and then you have the autocorrelation peak, and you have to figure out that you do this automatically.
No.
That's actually.
That's not automatic.
So how do you do?
At the moment, the default value is 3535 for the right limb, and there's no automation for that.
But that's an important one. It's very tedious, very painful, but important.
I think Xiang Yang could go into that. Or you.
Right, it really makes a difference.
Yeah, we will. I agree. I didn't think about it, but that's just.
And the second question, once you run out of work, occasional symmetry finder, and that's for people who work on lighthouse complexes and things like that. That's a very useful one.
I'm not sure if what you're referring to is down here in our specific scripts, but okay.
But that's another one that you use every now and again and takes you forever to figure out how it works again. So any plans to, that's also a really quite useful every now and again. Are you planning to introduce this at some point?
So to find the rotational symmetry center within the unit cell after image processing.
No, when you have a ring and you don't have good resolution, you can actually spread it out and make this rotational Fourier transform and then see what the symmetry is of the ring.
I think that would be a specific script that you would like to use only occasionally on one image or one non-tilted image from the entire data set. So, what it would need is just a C shadow script that you throw into the specific script directory.
I don't remember anymore how to do this.
If you have one template, you can just send it to us or put it yourself into a specific script thing, and then that's there, right? I guess there are many applications for specific scripts or also standard scripts, and we can collect them and then just offer them as optional scripts that you can use or not use. And it makes also perfectly sense to use Spider and BSoft in these things as specific scripts, or even in the standard scripts. We did not include these, or actually threw it out before distribution, because otherwise we would have had to distribute Spider and BSoft also, and then installation gets more tricky. But if you use Spider or BSoft things in your scripts locally, we have to think about that later. It's very easy to add those to the C# scripts that are there, then run those. For example, we use Spider to put little text into the final result of your image processing. The text would say the name of the image and the tilt angle that image was. And you can draw a line where the tilt axis is in your final thing. With Spider, that's very easy to do. We just didn't want to distribute Spider also, so that's why we deleted all that before we switched.
And so as more and more people are going to use this and create their own little scripts, do you have any plans of making a sort of a centralized script collecting tool that people can go and deploy it and rectify it?
So what you did not show is the help function, which many times also over. But if you just go, just jump onto one of the variables with the right mouse click.
Yeah, I think that the config file beforehand wasn't
Okay.
but here at 2dx.org, it's meant to be a organizational site for all of 2dx, and as you can see in the documentation here, there's a manual and all the parameters are available, and my favorite part is everything here is discussable via add comments. And so anything you want to say about any of these parameters or any of the other help or any scripts that you have, we're going to add an uploadable scripts folder, I presume, later, and also add the option of allowing people to write extra comments to the manual. So we want this to be very community-based.
Can I ask one more question?
Yeah.
I think it's fantastic. I just wanted to ask what you think are the next things that are most important to develop.
In terms of image processing generally, or in terms of 2DX? I think my favorite one so far was the image masking part of it. I think there's some disagreement on what types of image masking is best, and how to best mask real space images. And so it was suggested to me that we just go ahead and take real space images and quickly generate FFPs for particular windows and be able to mask these based on polygonal selections. I'd like to see a lot more automation myself in general. Automatic lattice finding based on statistical methods. The CTF is already found automatically. Automatic spot selection. All of these things already exist, but I'd like to see more on as many parameters as possible to give everybody the option of automation.
Another option would be the manager.
Yes.
Where you have the entire project of your production channel or so, and you will have one field like an Excel sheet where you have one line, one image, the field geometry, the IQ statistics, the quality of the image, and you can click this line on or off, and then say all that I've selected should be merged into a 3D in one button. And then once you have the 3D using Vectran, you can then reprocess all the images on the distributed cluster using 2DX with orthographic user interface remotely, and then in cycles. So we started working on that. That will take, I guess, half a year or a year to happen.
Also, the merging, of course, at the end, I think is the most important, because as I said, we need to have volumes for this to be useful. And I'd like to do a lot of the visualization that we've done here in 3D also.
Do you think it's
So
going to
maybe we have time this afternoon to
Yeah.
do